Okay, so to continue from last Friday, we were talking about, of course, databases, SQL, but we ended on this data projection activity where we wanted to know how many games each publisher had published. That means that we were going to, of course, have a select statement that had a group by clause here, where we group them by the publisher ID, and then we project it down and aggregate the number of games that they've published. That was still not that satisfying because when we did that, we ended up with just a raw publisher ID. 1 for LucasArts, and they published 3 games. 5 for Nintendo, and they published 5 games. What we actually wanted was the name, which is stored in a completely different table over here, the publisher table. And so what we need to do is we need to take these two tables and we need to join them together. Now that has a very fundamental, definition in mathematics. That if you've got a set A and a set B, that the cross join here, or the Cartesian product, is simply just each element over here is going to be matched to each element over here. And as we observed, when you've got a set of cardinality n and a set of cardinality m, then you take the cardinality and you multiply them together. So if I had 1,000,000 records in set A here and 1,000,000 records in set B, I would end up with 1,000,000,000,000 records total. All right? That's the idea that we can go ahead and continue with here today. That I'm just going to go ahead and select everything from game join publisher. Now, if I just did that naively, like I did on Friday, we'll see immediately here that it's not going to work. GTA 4 was not published by LucasArts and Sony Entertainment and. Why? Because this is just a pure cross join, right? This is a pure cross join, right? Joins every record in A to every record in B. Now, if you're mathematically, that makes sense, but is that what we want? I only want to join them so that this game was published by this publisher over here. Let's take a look at the ER diagram again. How are these two tables related? Over here in the publisher table, a publisher is identified by their primary key publisher ID. Over here in the game table, the publisher of that game is identified likewise by the publisher ID. So I'm going to put in here a condition, join only on the publisher ID, these matching. To do that, I'll select everything from game, join, publisher, on, and I'll go to the next line here because it's going to get too long, on game dot publisher ID is equal to publisher dot publisher ID. And when I do just that one, now that data makes sense. GTA 1, 2, 3, and 4 were all published by Rockstar Games. Legend of Zelda was published by Nintendo, right? And I'm not getting 300 some records anymore that I would get on a pure cross join. I'm only getting records that matter. That's where that relation comes in. Eventually, when you talk about relations in, say, 235, I previewed one on Friday where this is related to this only if this condition holds, if A divides B, or B is greater than A, or something like that, right? Some sort of relationship between those 2 points. A relation winnows that down to only things that are relevant. You can also use table aliases, right, to make your life easier. Select star from game as G, join publisher as P. So that on the second line here, all I have to do is go g.publisher ID is equal to p.publisher ID. Right? That saves me on some typing. I can save even more typing. This is so common to do. There. Same, there we go. Just delay there. Same exact results. Okay. That's pretty much it. You can't get any more. I guess you could omit the keyword on, I think. Nope, you can't. Never mind. You can't get it down any further than that. Right? So you can use table aliases. What else? All right, so does that get me what I want, first of all? I've joined everything together. What I want to do now is combine this, combine a join and a group by to get the original report. What I want is a list of publishers along with the number of titles they've published. Okay, that's my goal. So I will select, say, p.name and count of something. You'll help me on that here in a second. From from g dot game or from game g join publisher p on g dot publisher id is equal to p dot publisher id. There we go. And what am I going to want to count here? I'm going to want to group it. First of all, remind me, how do I do a group by clause? Group by how? Publisher ID. Now, is that going to work? Publisher ID, publisher ID? There are two publisher IDs here, one in the publisher table and one in the game table. It doesn't matter which one you group by as long as you specify one or the other. So I'll go with g.publisher ID. Right. What do I want to count here first? Well, let's just go ahead and count everything. Right. There we go. All right, so Ubisoft has published one game. I think it was Assassin's Creed. LucasArts has produced 3 games. Nintendo has produced 5 games. Right. That's a little bit less satisfying. Why? Count star. Is that a useful name for a column? No. So as number of titles. There we go. I don't know if I showed it to you or not, but you can do something like this. Number of titles. Did I show that? No? So what are these things right here? That's not a single quote. It's on your keyboard, right under the tilde. It's called a backtick. Right? So you can backtick to escape things out and get something that looks like this. Now number of titles. Now you can put in spaces. Gross, don't do that. Right? Spaces don't belong in anything in computer science. Right? But that is how you can escape things. If you wanted to name a table, select, my select table, you could technically do that as long as you used backticks. Don't do something like that though. Right? All right. You might be tempted, for example, in your project to name a table order. Right? If I ordered 50 pounds of grain or something like that, I'll go ahead and put that into the order table. Right? Don't be tempted to do that. Why? Order by, order is a key word. You'll end up having to backtick everything and then confuse yourself when it goes to actually query out of it. That's why we called stuff invoices, right, instead, so that you didn't have that temptation. Anyway, there's my report. Is that all the publishers, by the way? Nope. There are some publishers with no games. Right, let me go ahead and take a look at the publisher table. Select everything from publisher. Note here that Sony Entertainment, Square Enix, and Sega all show up. 3, 4, 5. But have they shown up in any of the reports that we've run so far? I don't see them here because they've not published any games. We're going to have a different kind of join. So to understand this, let's go to an example here. All right? I've got a student table and an email table. The implied relationship here is that one student can have many emails, right? Including 0. For example, Dale Sweem here. Do you see that he has any emails over here in this table at all? He has a student ID of 1122. Do you see that value over here in this table? Nope. Let's see. Sandberg, he's got 2 emails, cubbies.net and unl.edu. Rizzo's got 1 email and Castro's got 1 email. I really need to update this roster. These are Cubs, former Cubs players or managers. From the, I think he retired in the 90s technically. Right. Anyway, if I just do a regular old join, I get something that looks like this. Castro will be matched to his email. Rizzo will be matched to his email. And Ryan Sandberg here gets matched to both of his emails. But what happened to Dale Sweem? Did he get matched to anybody? Nope. What we want instead is what's called a left outer join, or just left join for short. What we want is something that looks like this. For any record that doesn't have any matching record in the second table, I'm going left to right. The record will still be preserved, but null values will be substituted for any missing data. Right? And that's the difference between a join, it's called an inner join, but we don't write the keyword inner. You can if you want. Let me go ahead and go back here and show you. Inner join, there we go. Same thing, right? But it's not usual to write inner join. We can go ahead and run this and instead do a left outer join, right? To preserve records from the left table to the right table. Again, it's so common, you might as well just write left join. Don't write outer. Right? Now, I'm about to execute this, and it's not going to work still. Right? It's not going to come back with Sony Entertainment with a zero number of titles here. Okay? Let's understand why. Which direction was I going? I started at the game table, and then I went over here to the publisher table. The order matters, right? You can join table A to table B, A to B, right? You read left to right, so A to B, or you can join B to A. In this case, I joined from the game table over here to the publisher table. Were there any records that were not being preserved? No, they were all preserved. Why? Because can you exist as a game record without a publisher record? Remember, this is a parent-child relationship. A publisher can exist without any children, but can a child exist without any parent? No. So I don't need to preserve records because of the way that I've designed this database. Let's reverse it. Let's start at the publisher table and then go over to the game table, right? So this is the incorrect order. All right. You go from game to publisher, but it is not possible for a game to exist without a publisher. So we need to reverse it. Sorry, there we go. So reverse the order. Go from the publisher table, publisher, to the game table. There we go. And all I'm going to do is reverse these. Put that down here and put publisher up here. I'm going from the publisher to the game table, and I'm doing a left join here. That will preserve any record in the left table joining over to the right table. So that Sony, oops, sorry. Let me show you that it actually works here without this aggregation. Let me go ahead and get rid of that. I'll just select everything there and get rid of that there. All right. Let's just look at the data and see what it looks like first. The publisher ID and the name now are on the left side. The game ID, name of the game, and publisher ID now are on the right side. Right? And any record that did not have a matching record on the right side is now preserved. Sony, Square Enix, Sega, all of those have null values for any games. Okay? I'm preserving records now. That's step one. Okay? Now what I want to do is perform the same projection and aggregation. Right? From publisher P, left join game G on that group by publisher ID. Actually, I don't want that. Let me go ahead and get rid of that for just 1 second here. No, I do want this. Sorry. All right. Let me go ahead and execute this. Am I getting those records still? Nope. Why not? So I'm going from the publisher over to the game and matching any record, and it is a left join, so it will preserve those. I'm grouping it by the publisher ID, but what am I counting here? I'm counting everything. That's not what I should be counting. Let's come back up here to this one. So LucasArts has produced 1, 2, 3 games. What should I count in order to sum those up? The game ID or the name or the publisher ID over here? Any of those would be good, but in general, what should you do? You should go with whatever is uniquely identifying to that record. So let's come back over here to the ER diagram. What uniquely identifies a game? What is that thing in yellow again? It's a key. A primary key is a unique identifier. So let's not count up just any old thing. Let's count up game ID. And I'll count it in the game table, G dot. There we go. Right. There. Sony Entertainment now has 0 titles. LucasArts now has 3 titles. I'm not getting them all, though. Right? That's because why? G.publisher.id. Let me come up here and show you again what it looks like. So, Sega. Here's the game table. These three columns right here are the game table. If I said game table.publisher.id, what do I get out of that? 0. Where do I want to group these? I want to group these by the actual publisher ID over here in the publisher table. So let me go ahead and change this to p.publisher.id and execute this once again. That's the final one, right? So I've got LucasArts 3, I've got Nintendo 5, Sony Entertainment, Square Enix, and Sega are all 0s. Why? Because I'm grouping them by their publisher ID over here in the correct table, the publisher table. I am counting the game IDs in the game table, and for any missing values, like these nulls, those will end up counting as 0, preserving those records. All right? So there is the final version of this. Now, do you remember in our, I demoed it in Python, where you actually had to open up the file, process all the tokens, store them as classes, iterate over them, count things up, maybe use a map or something like that. Be smart about it and take half of that code and eliminate it, and then use a map comprehension, right? Still, something in Python versus this one line of code in SQL, right? Use the right tool for the right job, right? Isn't that so much better? You're doing it on the server, you're taking care of all those details, right? And you're producing the same report. This is why there are DBAs, right? Most people want full stack developers. You know, what does full stack mean? Full stack means we don't want to pay more than one person. We want you to do everything, right? In any complex system, any complex organization, you can't have that. You have to have a lot of people doing a lot of different things. You will have an entire DBA team that lives in the database, right? They take care of the data, they manage the data, they run reports. And they might even have yet a separate team. We call them dweebies. Not database, what is it? No, data and business intelligence workers, or I don't know what they were called, DBIs. Where the database people, they just manage the database, and then the not Debers, but dweebies, I think they call them. They actually produced reports and ran reports, and then handed that over to the business people, who then promptly ruined all their work by dumping it into an Excel file and changing stuff, right? An Excel file is not a database. You can do so many more powerful things in a database, just like this. All right. All right. Questions on joins? Otherwise, let's do some exercises. Right. Yeah, go ahead.
Why can't you just instead of going through all that, why can't you just write one in to get?
Oh, good point. So let me go ahead and get rid of this. So there's a write join. Right? That will preserve records in the write list. So let me go ahead and execute that. And now we're missing all those zeros again now, right? Why? Because we went from left to right. So if you want the exact same query, then we need to switch these back. And now it's a write join. And this is the exact same thing. Are you going right to left or left to right? Which one's more natural for the vast majority of people in here? How many people read right to left? Nope. How many people read left to right? Majority of us. And that's why I don't generally use write joins. We'll have cause to do it by the end of the day, maybe. We'll need to do it. But generally, if I can go left to right, I do it. Right? Why? Because I read left to right. Right? So our next exercise here is going to be just that. I'm going to flatten this entire database model down to a CSV file by starting at one end, publisher, joining over to the game, joining over to the availability, joining over to the platform. Left, 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 left. You could go ahead and start at the platform, right join, right join, right join, but then you're just going to the other direction. So yes, there are right joins. The order matters though. Right? So here's our final exercise. Flatten the entire data model, right, into a CSV-like query. In other words, I'm going to dump all the data so that I can then produce a CSV file and then give it out to students so that they can run their reports in Python instead, right? That's exactly what I did. So I'm going to go ahead and, join all 4 tables together. Here's my first attempt. Select everything from, I'll go ahead and start at the publisher table, publisher P, join, I like to start each line with a keyword, so I'll go ahead and put a publisher at the top, join game G on, and I'll keep that on one line, p.publisher, publisher ID is equal to g.publisher ID. The order here doesn't matter. A is equal to B is the same thing as saying that B is equal to A. But I like to go in the same order that I'm going in the tables, so I'll keep it like that. Join availability A on g.gameID is equal to availability.gameID. Why did I know that that was the primary, or how did I know that that was the foreign key relationship between those two tables? I didn't have to look back at my ER diagram here, right? Game ID matches to game ID. Why? Same name, right? The amount of cognitive load you can take off by having sensible column names and variable names, it cannot be underestimated, right? Now, join to platform P on a dot platform table, or platform ID is equal to p.platform ID. Again, did I have to look at my ER diagram? Nope, I just remembered it. There is going to be a problem here, though. Can anybody read that? Non-unique alias P. I had a publisher table that I aliased to P. I had a platform table that I aliased to P. So can you use the same alias for 2 different tables? Nope, ambiguous. So I'll go ahead and shorten this to plat and plat. There. One big giant data model, right? There's the publisher table. These 3 are the game table. There's the availability table, published in 2005. LucasArts did on Lego Star Wars. And there's the platform table. They published it on Xbox originally, right? Makes sense. Except that, am I getting all of those producers or publishers, I guess, that had no games? Nope. Because I was doing a regular old join. So let's do a left join, left join, left join. Execute that. Sony Entertainment, Square Enix, Sega. Nulls all the way to the right. Let's rethink that, though, before we move on. Where do I have to left join? Where do I not have to left join? Where is it required? Where is it not required? So we've already seen, going from the publisher table to the game table, that it's required. Why? Because a publisher can exist without a game. What about game to availability? Can a game exist without an availability? Yeah. Can an availability exist without a game? Nope. So if we've already got a game over here, right, then do we need to left join if it's not available on any system? Well, ultimately, we're going over here to the platform table. Do we need to left join to the game table to see that there's no record in the availability table and thus no record over here in the platform table? Let's find out. What if I don't do left joins everywhere? All right? Actually, undo. Let's take a look at this. And let's think about maybe a record that would not end up showing up. Blizzard, let's see where. I'm looking for, there we go. There is Mega Man 4. That was an intentional mistake. It was not published by Eidos, but that's what the data says. Mega Man 4, which was actually not available on any system. All right? So remember, Mega Man 4 here. If we don't do a left join, all the way over. Let's see if we still get that record. And I'm going to go ahead and sort this so we can see Mega Man 3. What happened to our Mega Man 4? It got lost. Even though it had a publisher, even though it had a game, it was not available on any system. So therefore, going from the game table over here to the availability table, we lost that data with just a regular old join. So let's restore that. And do I have Mega Man 4 now? I still don't have Mega Man 4. Why? So, record, preserve that record even though there's no record over here, but then lose that record when you go all the way over to the platform table. So, do we need left joins all the way over? Yeah, if we want to preserve all those records, yes we do. All right. There we go. And where it happened to Mega Man 4. Mega Man 4, right there. Okay. All right. Let me take a look at all of the platforms that we have in this database. From platform. There we go. Xbox, Xbox 360, ... all the way down to Super Nintendo. Let's get some modern. So give me a platform, a more recent platform. And as a review, how do we get stuff into the database? Insert into platform. What do we need for the platform? Just the name. The platform ID will automatically be generated for us. Name, values. Give me a platform. Say what? Oh, okay, PS5. PS5, there we go. Give me another one. Okay. Y'all are thinking consoles. Think outside the box. I've got a Switch. I don't want a PS5. I want a Steam Deck. Right? That's cool, right? I don't know, is it or not? Anybody have a Steam Deck? I saw one person last semester playing it in a lab up in Omaha. And hey, that's a Steam Deck. I didn't. They had a shortage. It's the handheld one put out by Steam. Right? You can play. It runs Linux, and it plays anything from the Steam store. Anything from the Steam store. There might not be some things that can rerun on it, but anyway, Steam Deck, and then even more, not more recent, but even cooler, Valve Index. There we go. Anybody have an Index? All right, super cool. All right. And there, we'll go ahead and do that. Let's go ahead and put all 4 of those in there and make sure that they were actually in the platform table. So PS5, Switch, Steam Deck, and Valve Index. All of these are brand new or relatively new platforms, so certainly there are not going to be any games available on any of those platforms. So let's come back over here to our query and see if we preserve those records. Right, there you go. So a bunch of null values, games that are not available on any system. Game Boy, Mac, NES, PC, PS1 through 3, Super Nintendo, Xbox, and Xbox 360. Do you see those 4 platforms represented here? Nope. How am I going to get those platforms starting over here at the publisher table? Going from publisher to game to availability to platform. Left join, because it's in that order. Right? Can I do a left-right join, right, and preserve both? Yeah, there's a way of doing that. But let's go ahead and think about going in reverse. All right, so here's my reversed query. Preserve records from the right. Right? So let me go ahead and just grab this and change all of these into right joins, and right joins. Right? I could go ahead and go with the left join as long as I reverse them all and start it over here at the platform table to the availability table to a game table to a publisher table. Let's see what that looks like now. And let's sort over here. And now I see that Valve Index, but is it available on any system? Nope. Null's to the left now, right? Because it's a right join. There's the Switch, there's the Steam Deck, and there's the PS5. They're now represented. Did I lose anything in translation? What about that Mega Man 4 that I know is in there? Look as though you might, it's Mega Man 4 or Mega Man 3. I forget. All right, anyway, I'm missing a whole bunch of games here because I'm missing publishers now. So, come on. Let me sort it by the publishers' names. Right? Do you see Square Enix? Do you see Sony Entertainment? Nope. So I started at one end, did a left join. I started at the one end and did a right join so that I would preserve records from the left and the right. Right? How can I go ahead and do both at the same time? Let me try this. Left, right join. Left, right join. Left, right join. I very much doubt that this will work. In fact, it's telling me it's not going to work because it's not even correct syntax. You can't go both ways. Right? All right. That's not going to work. Right? What if I took both of these results and I combined them somehow? Oops. We want to combine two result sets. Right? In fact, let me go ahead and emphasize that. Sets. If you have two sets, how can you combine them? If you have that set from A, A is equal to A, B, C, and let's say that B is equal to C, D, E. There we go. How could I combine those two sets? What kind of operation would allow me to combine them? A union or cup B. In this case, what would that produce? A, B, two C's? Nope, because that is a multi-set, and this is just a regular set. So go ahead and get rid of what one? There we go. By the way, what's the other one? The opposite. The cap. It's called the intersection, and that would result in what? What's in common to both is going to be a C. Okay? All right, so let's try doing that as a union. Guess what? The key word is union. All right? Let's go ahead and combine all of those together there. Right? And now you see things that are preserved on the left-hand side, Sony Entertainment, with null values all the way to the right. You see things that are preserved on the right-hand side, PS5, with nothing on the left. Right? What if you just wanted things with no nulls? Intersect. Or intersection, is it? What is it? I don't even remember. Join, union. I guess you can't do that. Intersection. Nope. All right. Fine. I'll just do union. Anyway, the way to think about these things is a result set. That's a result set. That's a result set. You can combine them by having a union. And by the way, there are things that would appear in both, but are they going to be here twice? No, because that's not how unions work. All right, question? No.
Is an inner join the same as an intersection?
Inner join is going to be just a regular old join. Right? You can take an inner join and then remove the keyword inner, and it's just a regular join. It will not preserve records from the left or the right. Right? And that's what I wanted to do here. I wanted to preserve records both left and right, and then combine them into one. There might be another. There's more than one way to skin a cat. There might be another way to do this. So reserve records in both directions, and union them together. Now I will have a word of caution here. I do have it in here. Where's my little pretty picture that I stole? Every so often, especially if you go to SQL tutorials, you'll see something that looks like this. This is unfortunately a terrible visualization of what joins mean, because joins are not set operations, right? This thing over here, this is the intersection, this is the union, this is the disjoint intersection or the exclusive or, right? This is set minus, this is set minus the other way, right? This is a terrible way of visualizing it, because that's not how joins work. Joins are a Cartesian product of two things. not necessarily just a union or an intersection or a set minus or something like that. You can do those operations after you've done a join, right? So did you see this? Yeah, this is unfortunately, this is a terrible way of looking at it, because an intersection or a union is not just a full outer join, right? Because it's a different operation. It's the difference between union and the Cartesian product of two sets. Right? Okay. But, caveat emptor, beware that there's this visualization out there. It's the wrong way of looking at it. Right? I don't know if I should have shut that or not. What else do we have? What else would you want to do here? Let me go ahead and put this into the... What kind of other reports can you think of? Just by looking at this. There are lots of things that you could do. You could determine how many games are published on each platform. That was the other exercise that we did, was it? Let's do that now. All right. So how many games are published on each platform? Where should I start, first of all? I should probably start at the platform table and then go over to the game table and sum up the number of games, or count up the number of games. So let's go ahead and select star from platform, just to look at all the platforms. Now I need to go over to the game table, or do I? Let's go ahead and join availability on platform, or let's go ahead and alias this, p dot platform ID is equal to a dot platform ID. Is that going to give me everything? What happened to that Steam Deck? What happened to that Valve Index? They're not there. What kind of join did I need instead? A left join? There, it's preserved there. Why didn't I do a right join? Because I started at the platform table, and then I put on the availability table. If I had started the availability table and put on the platform table, then I would have needed a left join. Or if I started the platform table and go over to the left, right, right? Just get your left and right correct. Right? In this case, I'm going from the platform to the availability, preserving records. Now, do I need to go all the way over here to the game table? I've already got a record of the game ID right here. Why don't I just sum those up? Right. So platform P, select everything. Let's go ahead and go with p.name as platform name. Form name, right, comma. Let me get rid of this. Give myself some more room. What else do I want? Some count of something. From platform P, join availability. Right. Now, by itself, I'm going to get 30. An Xbox? Does that make any sense? Everything in my database was published on the Xbox and the Xbox only. Right? Where's that 30 coming in? I'm counting every single record. Right? And I'm not grouping it by anything. So if you can do it without grouping by, but then you get weird results. So group by what? What should I group it by? If I start at the platform table and go over to the availability table, ultimately what I want is a list of platform names along with the availability, the number of games that are available on that platform. So what should I group it by? Platform ID. Right? So group by p.platform ID. There we go. Xbox all the way to Valve Index. But does that look right? Xbox, there's only one game on there. Xbox 360, 3 games, 8 games on the PC. Right? Those all look right, and they probably are right. But what's not right? PS5, Switch, Steam Deck, and Valve Index are all counting as one. Right? So do I want to count everything? Nope. Let's go ahead and just get rid of this for a second and see what we're getting back over here. Right? Do I want to count the number of, let's go ahead and sort it by the platform ID. Do I actually want to sort it, do I actually want to count the number of rows? Or what do I want to count so that these nulls end up being 0? I could count game ID, I could count platform ID, I could count year. But generally, you want to count things that are unique. What's unique with respect to the availability table? Availability ID. So let's count just that. A dot availability ID. There we go. There. PS5, Switch, Steam Deck, and Valve are all now zeros. Okay. 2 lines of code with a relational database system got you basically everything that was in that first assignment that I've assigned before, the first exercise that we did. All right. Anything else that you want to see? No? Okay. All good for lab on Wednesday then? Yes? It's good? Okay. All right. All right. Then what we're going to do next is database design. So we started out with a database, creating and designing databases. All right. So designing basically, in fact, what we're going to do, we'll design a database to support our little financial asset application. Right? We need to support what was it? The owner, which is a person, their emails, right? Any number. We need to support 2 different types of accounts. What was it? Annuity and savings. Right? So let's just spitball this. Let's go ahead and whiteboard this, at least in our heads. Right? How many tables are we going to need? What's at least one table that we need? Person table. Okay, I'll buy that. What else? What? Emails. There we go. Why? Because one person can have many emails. Right? Okay, that's 2. Okay, an account. All right, an account table. Right. And now, what about a person to an account table? One person can have many accounts, right? Because you have an annuity. I had like 4 accounts in the demo that we did in Java. Can one account have multiple people? That's not the model that we went with, but maybe that's the model that we want to go with. There are joint accounts, right? So some variation here. We now want to support joint accounts. Accounts with more than one owner, right? So what kind of relationship would that be if we wanted to go with that model? Many to many, right? So what am I going to need between a person and the account table to join them together? A join table, just like this availability. So already this exercise is sounding eerily familiar. How many tables did we just identify? 4. How many tables do you see here? 4. It's probably going to be something very, very, very similar, right? That's just to get you through the basics. There's a one-to-many relationship. There's a many-to-many relationship. You need at least 4 tables. But another way of looking at this is, think back to that Java demonstration that we did. How many classes did we have? 1 for a person. And how many for accounts? Ultimately, we did an inheritance hierarchy where we had an account, an annuity, and a savings account, so 3. I'm going to take that concept and I'm going to collapse it down into 1, right? In other words, just think about accounts. An account object, we call them POJOs, plain old Java objects. An account object has a direct relationship to a table. A person object has a direct relationship to a table. What about emails? The string class has a direct relationship to a table as well, right? If you want to look at it that way. So generally, what you're looking for is a nice one-to-one mapping from your Java to your database. That begs the question here. How should we handle inheritance? Right? Should we have one table for all types of accounts? Should we have 2 tables for each of the non-abstract account types? Should we have 3 tables, 1 for each class? So which one sounds, here, let me go ahead and put them in bullet points here. A, B, or C? There we go, there. Indent more, indent more, indent more. How should we handle inheritance? The relational database model predates object-oriented programming by at least, what, 20 years almost, right? So in other words, they weren't thinking about inheritance at all back then, right? It wasn't codified until 15, 20 years later. These are 2 fundamentally different models of data. One is inheritance, one is a relational, right? How do we reconcile those 2? These are 3 strategies right here. This first one is called a single table inheritance hierarchy strategy. The second one is a table per subclass, and the third one is a table per class. Which one sounds easiest?
3 tables.
3 oh, why does that sound easier?
Or just separate it all.
Okay, you separate it all. Think forward though now that you're gonna have to query stuff out of the database. Join. All right. So, as with everything with design, yes, one thing is easy, another thing becomes hard. And just flip that around. If we went with A here, a different thing becomes easy and other things become hard, right? So in other words, there's no wrong answer here. All 3 of these are perfectly well-established approaches and strategies. I'm gonna go ahead and go with 1 because I don't like writing a lot of stuff, all right? That's the one that we'll use. If you wanna do the others for your project, that is perfectly fine. But I'll warn you, you're gonna be writing a lot of queries. Right? Right. But it's perfectly fine to do that. That's where we'll pick it up on Wednesday then. Wednesday and Friday, we'll go ahead and do database design with this, you know, financial asset application in mind. Okay.